Welcome to the absolute convergence theorem. So recall, we had a series, which is the sum from n equals 1 to infinity of a sub n, converges absolutely if the sum from n equals 1 to infinity of the absolute value of a sub n also converges. Or if the sum of the absolute values converges. So what would be great is if absolute convergence guaranteed just conditional convergence as well. And we actually do wind up getting precisely that. So essentially what we have is if the sum from n equals 1 to infinity of a sub n converges absolutely, then we get two statements. First up, the sum from n equals 1 to infinity of a sub n also converges. Right? So if it converges absolutely, it also just converges regularly. We also get a slightly odd statement is if the sequence b sub n is simply a reordering, so is a rearrangement of the a sub n sequence, then we get the sum from n equals 1 to infinity of a sub n is exactly the same as the sum from n equals 1 to infinity of b sub n. We will take a look more at this odd statement in the next video. For this one, we're just going to focus on the first one. So essentially, if we have absolute convergence, then that means that the absolute values of our a sub n's are going to zero fast enough for convergence, even when it's all being added together, right? And so essentially the a sub n's become negligible at the end, right? So our absolute value of a sub n is essentially negligible for large n. Right? Well, if the absolute value of a sub n is negligible for large n, the same holds for a sub n. And so the a sub n's will also go to zero fast. And we add in some up down, but we're still going to zero, so it'll level out. Right? So we add in some up down, but it will level out, right? If it continued oscillating, if it didn't limit on something, then we also wouldn't have our sum limit on something, right? So the a sub n also go to zero fast. We add in some up down, but that makes the sum settle even faster. Right? If adding all these positive values limits on a finite number, then adding in some positive and negative is not going to make a difference to that. Essentially is what is going on. So again, in the last video for this section, we're going to focus on the second statement, where if B sub n is a rearrangement of A sub n, then our series is equivalent. The reason why this is such an odd statement is because this requires absolute convergence for this to be true. So in the next video, we'll take a look at an odd case and see how this can fail if we only have conditional convergence.